All right, today's lecture is going to involve us looking at multi-step problems. We're going to stick to just two-step problems for tonight, which means we're going to add more islands from our stoichiometry map. All right, before we begin this example, please copy it down in its entirety, including the chemical equation. Got it? Good. We are asked to determine the mass of hydrogen required to react if 3 moles of oxygen react in this equation. So our strategy this time is to go from moles of oxygen, and we pick moles of oxygen because it has the number right here, moles of oxygen, okay? And from there we're going to go to mass of hydrogen. But we can't go directly to mass of hydrogen. If we take a look at our stoich map here, we are at moles of A right here, and we're asked to go all the way to grams of B this time. So it's not just the mole ratio. We need to go from moles of A to moles of B to grams of B. This is because they're asking us to go from moles of oxygen to grams of hydrogen, and the only way to get from here to here is to get to moles of hydrogen first. So our strategy is a little different this time. Let me shrink this back down. We're now going to go from moles of oxygen to moles of hydrogen, then we can go to grams of hydrogen. Now that tells us that we are going to have 2 conversion factors. So let's look at our known values. When we go from moles to moles, let's take a look again. From moles of A to moles of B, we need to build a mole ratio. So that's what we're going to do right now, okay? So looking at our equation, we have 1 mole of oxygen and 2 moles of hydrogen. So 1 mole of oxygen is equal to 2 moles of hydrogen, okay? We also know that 1 mole of hydrogen is equal to 2.02 grams of hydrogen. You have to remember your Brinkelhoff. Okay, let's take a look. To get from moles to grams, we need the molar mass of the periodic table. Hydrogen is 1.01 grams, and because it's H2, we have to double that. That's where the 2.02 comes into play. All right. Now we're ready for our calculation. We start with our given value and unit always. So we have 3.00 moles of oxygen. We have to get rid of moles of oxygen. And here we get to moles of hydrogen. Move this guy out of the way. And then we don't really want moles of hydrogen. We need mass of hydrogen, grams. Our numbers follow. 1 mole of oxygen to 2 moles of hydrogen. And for every 1 mole of hydrogen, we have 2.02 grams of hydrogen. When we multiply by 2, divide by 1, multiply by 2.02, divide by 1 again, we get 12.1 grams of H2 gas. So 12.1 grams of hydrogen is required to react with 3 moles of oxygen. Here's a second example for multiple step or island hopping stoichiometric problems. Please take a moment and copy everything down, including the equation. Okay, in this problem, we are asked to determine the number of moles this time of water that's going to be produced if 38.7 liters of carbon dioxide are also produced. So let's take a look here at our Stoich map. And we want to know how many moles of water are going to be produced if we have 38.7 liters of carbon dioxide. So we're starting out with liters, then we've got to get to moles of carbon dioxide. Then we use the new mole ratio to get to moles of water. So that's going to be our strategy. Liters of carbon dioxide to moles of carbon dioxide to moles of water. Let's capture that as a strategy. All right, so our strategy is liters of carbon dioxide to moles of carbon dioxide to moles of water. I'm changing the color when we change the chemical in case you didn't notice that. Our known values, liters to moles is always 22.4 liters of carbon dioxide, and that's always equal to 1 mole of the gas as long as you are at STP. We're assuming that in this example. And then moles to moles requires the mole ratio from the equation. So we have 3 moles of carbon dioxide to 4 moles of water. So 3 moles of carbon dioxide is equal to 4 moles of water. All that's left for us to do now is to write our equation. Oh, and I'm sorry. This should all be white. Okay. Let's get to the calculation. You always start with your given value and unit. Oops. Let me move this guy out of the way. So we have 38.7 liters of carbon dioxide. We're going to get rid of liters, so they go on the bottom, and get 2 moles of carbon dioxide, 22.4 liters to 1 mole. Then we build our mole ratio. We have moles of carbon dioxide that we want to get rid of, and we want to get to, oops, I forgot the white. Let me get the white back. We want to get to moles of water here. And we have, for every 3 moles of carbon dioxide that get produced, we have 4 moles of water that get produced. When we take 38.7 times 1 divided by 22.4 times 4 divided by 3, we get 2.30 moles of water getting produced. So tonight you've seen 2 examples, one where we start with moles and go to a different unit, and then one where we start with a different unit and we go to moles. Tomorrow night's lecture, we're going to have 3 steps where we have to just know that we're going to moles in the middle. Remember, the number 1 lesson here for stoichiometry and all of our island hopping with our mole map, or Stoich map, is the only way to convert between chemicals is to do it through the mole.